the beginning, the Sun and planets, including the Earth, started as a giant cloud of gas, which collapsed under its own gravity into a bulbous ring. The Sun formed in the center, and the planets further out. The red-hot surfaces of the growing planets then grew by being bombarded with debris as they collected up the remaining stuff in the disk. When the Sun began to shine, the atmospheres of the planets closest to it were blown away. But the planets further out were left much as they were, with their original thick atmospheres and their collections of moons. 15 years ago, the outer planets were unexplored. They were only known from observations made from the Earth. This movie, shot through a telescope, shows the giant planet Jupiter. The shadow of its planet-sized moon, Io, is crossing the atmosphere. This is Saturn with its rings. Uranus, Neptune and Pluto are so far away from the Earth that they can't be seen with the unaided eye. NASA planned to explore this unknown domain with 2 robot spacecraft, Voyagers 1 and 2. They would exploit a gravitational trick whereby close encounters with planets sling spacecraft onwards like a catapult. This way, both spacecraft would visit Jupiter and Saturn, and one would go on to Uranus and then Neptune. These planets are so far away that the Voyager mission was to last 12 years. It would enlarge the known universe 10,000 times.
Elvis Presley is dead. At the age of 42, the tremendously popular king of rock and roll died of an apparent heart attack at his Memphis, Tennessee mansion. He left a monumental legacy.
4, 3, 2, 1, 0. 3, 2, 1, 0.
The first leg of the journey to Jupiter was to take 2 years. The spacecraft crossed the asteroid belt between Mars and Jupiter and survived. Mission Control is the Jet Propulsion Laboratory in the foothills above Los Angeles, California. This computer animation shows Jupiter and its 4 planet-sized moons, the Galilean satellites. It was made to visualize the mission plan. The innermost, Io, was a special mission target.
First of all, we wanted a very close flyby past Jupiter's moon Io. In fact, we wanted to fly through what's called the magnetic flux tube linking Io to Jupiter. From there, we wanted to proceed on to Saturn, flying as close as we could to the giant moon Titan, and then on behind Saturn in such a way that we could watch the radio beam being transmitted through Saturn's rings. Those 3 geometrical considerations basically determined entirely our Voyager 1 trajectory.
Saturn's moon, Titan, was known to have an atmosphere, and some hoped that the place would be warm enough to sustain extraterrestrial life. The Voyager spacecraft were carefully designed to allow them to observe places that had never been seen before.
Now, because we didn't know exactly what we were going to see at Io, or in fact anywhere else at Jupiter, or at Titan, or of the rings or Saturn, NASA chose a very wide range of instruments so that we were not prejudging what it was we were going to discover. For instance, not only was there an imaging system included, in fact 2 imaging systems, both a narrow-angle camera with a 1,500 millimeter focal length, but also a wide-angle camera with a 200 millimeter focal length, which of course give us the visual information. But we also have instruments which look at the infrared radiation coming from the planet, the heat, if you like. That's this infrared interferometer and radiometer, and another instrument which looks at the ultraviolet emission coming from the planet. We also had radio receivers on this spacecraft, really for the first time that we've ever flown radio receivers on a planetary mission, to listen to the radio waves coming from the planet and the environment. These 2 antennas are, in fact, part of that radio reception system. And that's also an important part of listening with our ears as fully open as we can For instance, if there's any lightning in the planetary atmospheres, or if there were any electrical discharges perhaps associated with Saturn's rings, these radio receivers would monitor that information for us.
2 years out, the spacecraft approached Jupiter, the largest planet in the solar system.
This is the man they call the father of the revolution. And this is the moment that millions in Iran have been waiting for. After his long years in exile, the first hesitant steps of Ayatollah Khomeini on Iranian soil.
This is the actual sound of the radio emissions from Jupiter. The planet is approximately 1,500 times bigger than the Earth. Highly colored clouds swirl in its giant atmosphere. Jupiter is not solid, but made mostly of gas, those same primeval gases from which the solar system formed. This place is 500 million miles from the Earth, a planet so big that it's almost like a sun in its own right. The atmosphere has a great red spot, like an enormous storm, 3 times the size of the Earth. This environment is extraordinarily turbulent, and yet it's known that some features, like this red spot, are very long-lived.
In fact, what we see are these different islands of color which persist sometimes for hundreds of years. And this is a very amazing thing and very difficult to explain. Why should these fluid features exist for so long in the presence of all this turbulence, really? The movie here shows pictures of Jupiter taken once every time the red spot was beneath the spacecraft. That means every 10 hours the shutter was snapped. Then this is played in a sequence over and over again so you can see motion. Look to the west of the red spot, you can see this turbulent, rapidly mixing region. You can see rapid flow to the east at the equator. Just above the equator, you can see another turbulent region. And this rapid mixing makes the existence of permanent, different colored, different chemical features even more mysterious. For instance, some of these features, like the red spot and the belts and zones, and some of the ovals have lasted for decades or even hundreds of years in spite of all this rapid mixing.
This is a computer simulation looking along a line of spots in Jupiter's atmosphere. The problem is, how does anything have any permanence in this turbulent environment? The answer comes from studies like this one, which shows that not only are spots quite stable, but that they gradually merge, so that in the course of millions of years, the smaller ones are eaten up. This is the surviving predator. Jupiter has a very faint ring. This animation illustrates that it's made of millions of separate little moonlets, like boulders. Beyond the ring orbit 4 planet-sized moons, the Galilean satellites. This is the outermost, Callisto, which is made of ice and rock, and is roughly the size of the planet Mercury. Callisto's surface is covered in impact craters. This is the record of an intense meteorite bombardment. It dates the surface back to the very beginning of the solar system, when Callisto and all the other moons and planets were formed. Nothing appears to have happened to Callisto since. In this enhanced image, the impact craters are standing on the surface, shoulder to shoulder. From Callisto inwards to Ganymede, which is slightly larger. Ganymede has a composite surface. About half of it is densely cratered, like Callisto's, and is therefore very old. But some parts of Ganymede have many fewer craters. This is evidence that before the meteorites stopped falling, the original impact craters were somehow erased from the surface. In other words, because there are few craters, this surface is young. The terrain is marked with grooves, like the one at the bottom left of this image. These grooves have as yet no explanation. Moving inwards to Europa, the size and composition of the moons changes. Europa, which is smaller, has almost no impact craters at all. This is the frozen surface of an ocean of muddy water. Europa was once liquid and froze only after the meteorite bombardment had come to an end. It's possible that there may still be water underneath this ice. The innermost of the large moons orbits close to Jupiter itself. It's called Io. The mottled red and yellow surface is scarred with craters, which at first seem to indicate that the landscape was quite ancient. However, the craters on Io were not made by meteorite impacts, but by something else altogether. The scientists whose job it was to interpret these pictures couldn't at first work out what was happening here. The surface is crossed by distinctive low cliffs and stained with drifts of some kind of snow. The critical discovery was made not by a scientist, but by a junior engineer in the optical navigation team.
Voyager 1 encounter with Jupiter, I was doing my job of optical navigation and looking at pictures of the satellites of Jupiter and stars to tell us where the spacecraft was. In so doing, I was looking at a picture of Io in particular, and this is the frame right here. I expected to see the satellite Io and 2 stars in the frame. I used the capabilities of my computer to enhance the signal of a very dim star. And in so doing, I noticed the appearance right off the limb of Io of an anomalous crescent. And my first impression was that this crescent was another satellite behind Io. By analyzing trajectory geometry printouts of what objects might appear in this frame with Io, it was determined that no known satellite would appear in this frame with Io at that time. My next thought was that, well, this was perhaps a newly discovered satellite, but at this distance, this object would be too large and too bright to not have been discovered before from the Earth. I contacted a camera expert who informed me that no known quality of the camera could induce the appearance of this anomaly. Therefore, the only alternative that was left in discovering what this anomaly was that it in fact did have something to do with the satellite Io. I have determined the latitude and longitude in the region of this crescent on the surface of Io. This turned out to be the latitude and longitude of a large heart-shaped feature on Io, already known to be a volcanic feature, but of course not ever believed to have been an active volcano. I concluded that what we were definitely witnessing was an active volcanic eruption and that the crescent itself was a dust cloud of gas, an actual volcanic eruption, the first ever witnessed on a body other than the Earth in our solar system.
This black and white spacecraft movie of Io shows several eruptions taking place at the same time. Io's volcanism is thought to be powered by a collusion between the giant tides in Jupiter's atmosphere and a curious periodicity that Io's orbit has with the orbits of the other Galilean satellites, which can be seen here moving around the planet. This animation shows their orbits from Europa's point of view. For every 2 orbits Io makes, Europa goes around Jupiter exactly once. This gravitational lock holds Io in position, while the gravity of Jupiter's tides squeezes the moon out of shape and violently heats up the interior. This is the surface of a place so volcanic that it's turned itself inside out during its lifetime. The gigantic flames of erupting volcanoes, seen here on the horizon, illuminate a landscape made of nothing more than pure sulfur.
Well,
We'll start out with the simple kind of sulfur you'd buy from your pharmacist called flour sulfur. It's simply yellow sulfur. As a matter of fact, on Io, at very, very cold temperatures, this yellow sulfur is virtually white. What we'll do is heat this gradually. Now you can see the color starting to slowly change. This is the next form. It's an orange form of sulfur. If we were to cool this very rapidly, this sulfur would retain its color. As the sulfur continues to change, it becomes redder and very liquid. So some of the flows that we see on Io, which are orange and red, suggest that this very runny form of sulfur froze, retaining the color. As we go to higher temperature now, the sulfur changes again to a deep red and becomes much more viscous, like syrup. It runs much more slowly across the surface, forming cliffs on the flow front. And then the highest form, you can start to see here, changing, is virtually a brown to black form. It's this form of sulfur we see on the black spots that are scattered around on the floors of the calderas on Io. Suggests that the materials on the floors were heated to much higher temperatures, in this case about 300 degrees centigrade.
Besides being volcanic, Io generates 1 million megawatts of electrical power from edge to edge as it moves through Jupiter's magnetic field, more than the total electrical generating capacity of the USA. From Jupiter on to Saturn.
I, Ronald Reagan, do solemnly swear
that I will faithfully execute the office of President of the United States.
that I will faithfully execute the office of President of the United States.
And will, to the best of my ability,
And will, to the best of my ability,
preserve, protect, and defend
preserve, protect, and defend
the Constitution of the United States.
the Constitution of the United States.
So help you God.
So help me God.
Saturn is smaller than Jupiter, only 750 times the size of the Earth. This is what the rings of Saturn were expected to be like. An enormous collection of independently orbiting boulders and snowballs. And this is what they actually looked like. The structure is extraordinarily complex. A necklace with 10,000 strands.
Rather quickly created a ring movie from Voyager images, and if we can see that. The features appear as dark projections in the rings, and we'll see them rotating around. This was an absolutely startling discovery which was made. No one expected to be able to see these kinds of features in the rings. We always thought of the ring particles as very small, boulder-sized particles, which we would not be able to resolve at these resolutions. We see them as dark projections in backscattered light, and you see them rotate around. One of the things we wanted to do immediately was understand why these features maintain their shape in a ring which should be shearing with orbital motions.
The radial projections, which can be seen here orbiting within the ring, were called spokes for obvious reasons. Here they're seen with the sun behind the spacecraft camera, and they appear black. Seen from the other side of Saturn, looking towards the sun, in this view, they appear white, as they emerge from the shadow behind the planet. This is the way that fine dust behaves. For some reason, these clouds of dust are sweeping over the rings. Why isn't known. The rings are strongly influenced by Saturn's moons, which orbit further out. The small periodic changes in gravity due to the movements of these moons give the rings much of their detailed structure. This enormous thin disk of material, seen here in an enhanced image, is made of swarms of boulders. They are systematically cleared out of the orbits, which are exact multiples of the orbits of the moons, creating gaps. But this doesn't explain the entire structure. Right off the edge of the rings, and only just visible as a dot in this view, a tiny moon is orbiting. The presence of this moon is preventing the entire ring from drifting away into space. It's called a shepherd. Here, two shepherd moons are confining a single narrow ring. The gravity of small moons in orbit does the opposite of what one would expect and actually repels ring boulders. This animation shows the general idea. Long ago, when the solar system itself was a disk like this, the stuff that was to become us must have behaved in this same paradoxical way. Here, one of the shepherd moons is outlined against the atmosphere of Saturn itself. Nearby, and just visible to the right, is a thin ring. Saturn has a number of these very small moons. This movie, which shows the spokes, also shows tiny moons orbiting outside the rings. Their behavior can be very strange.
This peculiar-looking object here is one of the two so-called co-orbital satellites of Saturn. They're almost in the same orbit. In fact, their orbital radii are only about 50 kilometers apart. And these objects are more like 150 kilometers diameter, so clearly they're not going to be able to sneak by one another. They are closing in right now, and however, we expect there'll be some sort of a gravitational interaction that prevents them from actually colliding.
These two moons, called Epimetheus and Janus, move outside the rings in almost the same orbit. But it isn't quite the same, so the inner one is slowly catching the outer one up. Every 4 years they're set to collide, but as they approach, the gravitational influence of one upon the other causes them to exchange orbits. The faster one is slowed, and the slow one speeds up. Now they move apart. They'll meet again in 4 years' time.
But notice the very peculiar shape of this object. That strongly suggests that this is half of a single satellite. It was impacted perhaps by a meteorite that split it in two. And these two satellites now, almost in the same orbit, are the two halves of some original satellite.
These tiny moons, made of pure ice, orbit close to the edge of Saturn's rings. They are too small for their own gravity to compress their volumes into spheres, so they're irregularly shaped, like potatoes. They orbit in a zone that's periodically invaded by comets, so it's possible that they're merely fragments of larger moons, like this one, Mimas. Mimas is also made of ice. This pockmarked surface is disfigured by an enormous impact crater. Once, something large crashed into Mimas. It seems that Mimas may only just have survived.
We're going to pretend that these are comets, and we're going to fire these comets at rocks up there, which you're going to pretend are moons of Saturn. Now, actually, these shells only travel at about 1 kilometer per second, and A comet striking a moon of Saturn will be traveling at about 10. So the velocities are not quite right. What we're concerned about is the energy that we're putting into the satellite in comparison to the size of the satellite. And for that, our experiment is really quite satisfactory. All right, now we'll start with the smallest satellite, and then we'll work up to progressively larger satellites. All right, now let's look at the first case. The rock is gone, completely fragmented, and the fragments dispersed at relatively high velocity. And the second rock, which is here, we're just at the threshold of catastrophic disruption. Most of the rock is still here, but pieces are scattered about. If this had been the satellite, the pieces would just barely have separated, and the gravitation of the satellite would have brought them back together. Now we go to a satellite that's a little bit bigger for the same size crater, and we see that we formed a crater, in fact, and the rock was partly cracked, as we can see here, but pretty much it held together. And then we go to still a bigger object, and the satellite is now intact, and what we see is just the crater. And otherwise, the satellite is not damaged.
Mimas was barely large enough to survive. The next moon, Enceladus, is almost the same size, yet it looks very different. Part of Enceladus is cratered and part is smooth, with a few large cracks running over the surface. There are no large impact craters. The surface of Enceladus is a puzzle. As this animation shows, Enceladus, like the rest of the solar system, was made by a prolonged comet and meteorite bombardment some 4.5 billion years ago. After the bombardment stopped, some unknown process caused parts of Enceladus to be resurfaced from the inside, making the smooth plains. And later on, a much less intense bombardment took place, which lightly cratered the entire moon, including the plains. The resurfacing probably happened several times. It explains the appearance of Enceladus, but it doesn't provide any reason why the resurfacing happened in the first place. Enceladus, which is made of almost pure ice, is frozen solid and is an unlikely candidate for any sort of volcanic activity. In fact, this place wasn't understood at all until much later in the mission, when the spacecraft encountered Uranus's bizarre moon, Miranda, which is its almost exact twin. Enceladus, which is only barely spherical, is on the borderline between round and irregularly shaped objects. Moving outwards from Saturn, the moons get larger. This is Tethys, which is large enough to be round. Dione is almost the same size, about 700 miles across, and is covered with unexplained wispy markings. Rhea is bigger still, about 1,000 miles across. All these bodies are smaller than the critical size needed for the stable existence of an atmosphere. Titan, Saturn's largest moon, does have enough gravity to possess one. Titan had long been a favorite candidate for extraterrestrial life. But the surface turned out to be completely hidden from view by a thick layer of orange smog. Fortunately, the spacecraft was equipped with an infrared instrument.
This funny wiggly line is just loaded with information. We start at this end with a rather smooth part of the spectrum. We come into these interesting features here, ending up here with methane. So this confirms what we've already known, that methane is in the atmosphere. Down here we find ethane and acetylene. And this peak is very exciting. This is hydrogen cyanide, which hadn't been discovered before. It's exciting because hydrogen cyanide is a molecule that played a very important role in getting life started on the Earth. You can polymerize it to make adenine, which is one of the bases in DNA, the famous double helix, which gets us all going. And you can make amino acids if water is present, which was true on the Earth, but not on Titan. And so I should make it clear that we're not saying that because we have found HCN in Titan's spectrum, that we think life is beginning on Titan. But we do think that some of the chemistry that happened on the Earth before life began is probably happening on Titan today. And if we can study it in more detail, we can learn something about pre-life chemistry on the Earth.
Titan has an atmosphere made mostly of the gas methane, which is a useful fuel on our own planet. On Titan, the methane is being polymerized into the building blocks of primitive life. At present, this place is too cold for living things themselves to evolve. But in about 5 billion years' time, the sun will run out of hydrogen fuel and will expand to become a red giant. The Earth will be engulfed and destroyed. Titan, further out, will warm up and come to life. Regrettably, the precious warmth will last only a brief few million years before the sun shrinks back and becomes a white dwarf. Then all life in the solar system will come to an end. Beyond Titan, Voyager 2 took a distant look at Iapetus, one of Saturn's outermost moons. Iapetus was known to be half white, half black. On closer inspection, it turned out to be partially surfaced with black deposits like tar. Iapetus is an important signpost in the solar system. Voyager was moving into a zone where planets and moons begin to be made of quite different stuff. At Saturn, the trajectories of the two spacecraft diverged. Only Voyager 2 went on towards Uranus and Neptune.
It's almost a sacred color, yellow. This is a Kino symbol.
It is the power of the people that is manifesting itself now. So I am really counting on this landslide to offset any cheating that Marcos intends to do.
Uranus is 4 times the diameter of the Earth and orbits in a zone of perpetual twilight, 2 billion miles from the sun. The planet, its rings, even its poetically named moons and their orbits are tipped over on their sides. Before the spacecraft arrived, nothing was known about why this was so. This giant planet and its coal-black moons were a complete enigma. The planet itself is probably made mostly of water, but Voyager saw no ocean surface, only a high featureless layer of blue haze. Uranus has 9 narrow rings. They're made of billions of independently orbiting moonlets. The ring boulders themselves are made of darkened ice, like dirty snowballs. As this animation shows, one of the rings, the gamma ring, is slowly bouncing in and out. When the solar system formed, the planets and moons out here condensed from different materials from the ones further in. Ammonia and methane seem to be mixed in with the ice in these twilit regions, which changes its properties. In the event, the darkened moons of Uranus provided the key to how the whole planet might have been tipped over. This is the magnetosphere of Uranus, the structure formed by the interaction of the planet's magnetic field with the wind of nuclear radiation from the sun. In Uranus's case, partly because the planet is tipped over, this magnetosphere is very changeable. As a result, the surfaces of the moons in this environment are periodically bathed in nuclear radiation. This turns methane black. So the moons are darkened, like Oberon, the outermost of them.
The type of thing that we're looking for in a picture like this is evidence for what the structure of the planet is like, what caused it to be like this. And what we see are craters which have bright rays running out from them across a darker surface, and then rather darker areas in the center of craters. And what type of thing could create that? One of the simplest models that we have, and probably a correct one for this moon, is that it results from a layered structure. We have dirty, very rock-rich material deep within the planet, and then a cleaner ice layer outside that, and then on top of that, a dirty debris layer, if you will. And so what we're seeing over most of the moon's surface is this dirty debris layer, and when a large crater punches through that, it spreads brighter ice out over the surface that creates the bright rays.
As this animation shows, the moons of Uranus are made of rock and ice. The rock, being heavier, has collected into the interior. Most of the ice is quite clean, but the surface layer has been darkened by exposure to the nuclear radiation that bathes all these moons. So when the moon is struck by a speeding object, the impact can break through the crust of dirty material to the clean white ice below, spreading it out onto the surface. The other large moons of Uranus are also dark and cratered. They're named after characters in ancient mythology. This is Titania. Umbriel is the darkest of these moons. This is Ariel. None of these moons offered up any clues as to why the Uranian system was tipped over until Miranda, which is substantially smaller than the others and closest to the planet Uranus. Miranda turned out to be the key to the entire Uranian system. Miranda's size is on the borderline between round and irregular moons. Its bizarre surface is covered in grooves. There's an oddly shaped white feature, like a chevron, about 100 miles long. And giant cliffs of ice, more than 10 miles high.
It shows a fault which has broken the crust on what looks like a scissors fault, in which it's hinged back here and it breaks open like this. And the relief on that fault is of the order of 20 kilometers.
What appears to have caused all this is that Miranda was at first completely broken up and then reformed from its original components.
Let's imagine this beaker represents a portion of Miranda, the whole satellite being a round feature like this, with the ice having risen to the top and the rocks having settled to the center when Miranda was warm enough at one time for this separation to take place. Now we know from study of the satellite surfaces and a calculation of the rates of cratering at different places within the satellite system that Miranda has probably been broken up perhaps a dozen times by very large impacts in the same time that the craters that we see on Oberon were formed.
Now, if we imagine that the last time this happened, Miranda was smashed with a projectile, a comet nucleus, big enough to break the whole satellite apart, this nicely sorted arrangement of ice and rock would be distributed as debris that would go into orbit and would be mixed up in the orbit and spread out following the orbit of Miranda. Now, that debris won't remain there very long. It will want to collect back again into a satellite, rather quickly, as a matter of fact. But when it collects back in, the pieces that will fall into the satellite will come in different orders: icy chunks, rocky chunks, and so when we finish up, the final satellite will then be all mixed up and scrambled, looking quite different than it did at the outset. So we end up with a satellite then will look something like this. Now, of course, the satellite is not very happy in that state. The rocks do want to get back to the middle, and the ice wants to get to the outside. But it has to get warm enough for that to happen. Now, we can't wait for this to happen with rock. It would take millions of years. But we can do the experiment with a simple little device that you could buy about 20 years ago, which was called a lava light. This is simply a vessel that carries two different materials of different density. We can imagine that in this case, the part on the bottom is the ice that wants to rise to the top. The part above, the blue part, is the rock. Now, if you warm up the material, what will happen is that you can allow the lighter, icy material to rise to the top, or conversely, for parts of the rocky material that are on the outside to sink toward the center.
Long ago, after the time when Miranda had been broken apart into pieces, the moon was spread out along its orbit as a swarm of boulders. Half of these were made of rock and half of ice. Inexorably, the mutual gravity of all these boulders caused them to start collecting together until a new moon was born from the pieces. Whole again, the inside of Miranda warmed up, which allowed the lighter ice to force its way up to the surface, distorting it into grooves and cliffs, while the heavier rock sank into the depths. This rearrangement may have created the bizarre surface that was photographed by Voyager. The prominent chevron may be at the top of an ancient ice plume. This movie, which shows a flight over the surface of Miranda, was accurately made from Voyager images. Impact catastrophes may also explain the whole of the Uranian system. Perhaps once Uranus and its moons orbited as the other planets do, but a giant comet sought it out and tipped it over. The orbits of the moons were disrupted, and they crashed into each other, creating a cloud of debris that settled into a ring of material orbiting above Uranus's new tipped-over equator. This ring then condensed into a brand new collection of moons. Later, other comets passed through to smash these moons in turn. This probably happened to Miranda and all the other moons of Uranus several times over. It may also have been the fate of some other moons elsewhere, like the moons of Saturn. This is Enceladus. Its smooth plains are marked with telltale grooves. This place almost certainly shared the same fate as Miranda. It was broken up and reformed several times over, as were most of Saturn's other moons too. Voyager had discovered that the history of the solar system was unexpectedly violent. Halfway through the Uranus encounter, suddenly, the mission was interrupted by an unexpected event much closer to home.
And liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
The delay today had been for 2 hours due to ice, but the go-ahead was given in clear skies and near-perfect conditions. This was NASA's final command.
Challenger, go with throttle up.
Challenger, go with throttle up.
America's space program was grounded, except for Voyager 2, still in transit to Neptune.